In this lecture, we will talk about the rules of differentiation. Before we start talking about the rules of differentiation, I want to talk a little bit about the notation that we will use. So, you know from the previous lecture that if, for example, we have a function f of x equals x squared minus x, then we can find the derivative of the function using the limit definition. And in the end, if you remember, you get 2x minus 1. So if the function is x squared minus x, its derivative is 2x minus 1. Another way you can write this, so equivalently, we can write this information in the following way. We write d dx of x squared minus x equals 2x minus 1. So d dx means the derivative. So the derivative of x squared minus x equals 2x minus 1, which is exactly what we wrote down here. Or if you see that d dx of, let's say, x cubed equals 3x squared, then what does this mean? This means that the derivative of x cubed equals 3x squared. So this notation means derivative, okay? Or if you use this notation, then if our function f of x equals x cubed, then this tells us that f prime will be equal to 3x squared. F prime, the derivative, equals 3x squared. The notation d dx is very convenient shorthand for writing derivatives. So this is the one that we're going to use most of the time. All right, now let's talk about the rules of differentiation. Let's start with the simplest rule. Rule for a constant. Rule for a constant. So if you have a constant function, what's the derivative? Well, the derivative of a constant is equal to 0. Okay? For example, the derivative of 2 is equal to 0. So if you have a constant by itself, its derivative is equal to 0. And what's the reason? Well, the reason is if I take the function f of x equals 2, or any other constant function, then the graph of a constant function, so in particular f of x equals 2, its graph will be a horizontal line. This is the graph of the function f of x equals 2. And you see that the slope of the graph is equal to 0 because at any given point on the graph, the angle is 0. So the slope is always 0. And we said that the slope of the graph is equal to the derivative of the function. So if the slope is 0, then the derivative is also 0. That's the main idea for this rule. Okay? The graph of a constant function is always a horizontal line. Therefore, the slope is always 0. Therefore, the derivative is 0. Okay? If you want to find what's the derivative of minus 1 over square root of 13, again, this is just a constant. And by that rule, the derivative of a constant is equal to 0. Okay? So keep that in mind. That's the first and most basic rule. Now, the next rule is probably the most important one. It's called the power rule. Power rule. It's very basic, but we use it very, very often. So it says that the derivative of x to the n equals n times x to the n minus 1. So if you have x to a power, some number, its derivative will be n times x to the, and you basically subtract 1 from the power over here. So for example, let's say you want to find the derivative of x to the 5. Okay, so in this case, if you look at the rule, n is equal to 5. N is equal to 5. So if n is equal to 5, if this is 5, the derivative will be 5 times x to the 5 minus 1. So it's 5 times x to the 5 minus 1. So you get 5x to the 4. This is the derivative. Or sometimes maybe it's easier to think of this 5 kind of coming down. So it comes down, becomes a constant. And then you just subtract 1 from top. So you get 5x to the 4th. Another example. Let's say you want to find the derivative of x to the 4. Okay, now in this case, n equals 4. N equals 4. So if this is 4, your answer will be 4 times x to the 4 minus 1. 4 times x to the 4 minus 1. So you get 4x cubed. What about the derivative of x squared? Well, in this case, what's the power? What's the n? N is 2. N is 2. So if n is 2, the answer will be 2 times x to the 2 minus 1. 2 times x to the 2 minus 1. So you get x to the power of 1. But we don't write x to the power of 1. We just write x, right? So the final answer is 2x. What about the derivative of x? Well, first, let's talk about the power. What's the power in this case? Well, the power is 1, right? X is the same thing as x to the 1. So our n is 1. Our n is 1. So the answer will be 1 times x to the 1 minus 1. So 1 x to the 1, then we subtract 1. Well, if we do that, we'll have x to the 0, but x to the 0 equals 1. So this will be 1 times 1, you will get 1. So the derivative of x is equal to 1. Right? Let's do a couple more examples. Let's find the derivative of 1 over x squared. Well, notice that 1 over x squared does not look like x to the n. It doesn't look like x to the n. So we can't use the power rule directly. First, we need to rewrite 1 over x squared so it looks like x to the n. And then you will use the power rule. So how can I rewrite 1 over x squared? It's going to be x to the power of minus 2, right? 1 over x squared is x to the minus 2. And now we can take the derivative. Now we can do d dx. Okay? So now n is negative 2. So if this is negative 2, our answer will be negative 2 times x to the negative 2 minus 1. So this will be negative 2 x to the negative 2, and we have to subtract 1, right? So in the end, we'll get negative 2 x to the negative 3. Or if you want to rewrite it as a fraction, it's going to be negative 2 over x cubed. For the power rule, let's say you want to find the derivative of square root of x. Again, square root of x is not given in the form x to the n, okay? So just like here, just like in this example, you want to rewrite square root of x as x to the n. And once you write it as x to the n, then you can use the power rule. So how can I write root x as x to the n? Well, it's going to be x to the power of 1/2, okay? You all know this from high school. So now I can use the power rule. Now it's x to the n, where n equals 1/2. So if we use the power rule, what happens? So this is our n. So 1/2 x to the 1/2. And you subtract 1 from the power. You get 1/2 x to the, this will be negative 1/2. Or if you want to rewrite it as a fraction, you get 1 over 2 root x. Okay, so the point of the last two examples is that sometimes you have terms that are not given in the form x to the n. So this is not x to the n. This is also not x to the n. In that case, when this happens, you need to first rewrite them in the form x to the n. So here I wrote it as x to the minus 2, and this guy I wrote as x to the 1/2. And then you apply the power rule. So keep that in mind. Let's talk about the rules of scalar multiplication and addition. So suppose you want to take the derivative of a constant times a function. Okay? A constant times a function. Then we don't touch the constant, and we only take the derivative of the function. Okay? So the constant slides over, you only differentiate f. All right? So, for example, let's say you want to take the derivative of 4x cubed. Okay. So in this case, 4 is the constant. 4 is the constant, and f is x cubed. Okay, so this rule says that don't touch the 4. Okay, the constant is not touched, times, and you only take the derivative of x cubed. And by the power rule, the derivative of x cubed is 3x squared. So 4 times 3 gives us 12. So the final answer is 12x squared. Let's do another one. Suppose you want to take the derivative of 6x squared. Again, we have a constant times a function. The constant is 6, and the function f is x squared. So nothing will happen to the constant. So nothing will happen to the 6, and we only take the derivative of x squared. And by the power rule, x squared becomes 2x. So then if I multiply by 6, the final answer is 12x. When you have a constant, like in this case you have a 6, and it's multiplied by a function, when you differentiate, the constant doesn't change, right? The 6 stays 6. It moves over. But if you have a constant by itself, So if I look at the derivative of just 6 by itself with no function, then the answer will be 0. Okay? So be careful. If the number is by itself, if the constant is by itself, then the derivative will be 0. But if the constant is multiplied by a function, then it doesn't become 0. It stays the same. So keep that in mind. Suppose you want to take the derivative of the sum of two functions, f plus g. Well, you can do it step by step. You can first take the derivative of f and then add it to the derivative of g. And likewise, if you have f minus g, this will just become f prime minus g prime. Okay, so these are sort of basic rules that we expected to happen. So, for example, let's say you want to take the derivative of x to the fourth plus x cubed minus x squared plus x minus 5. Okay, you want to take the derivative. So this rule says that whenever you have addition or subtraction, you just take the derivatives separately, and then you keep the pluses and minuses in front. So we'll take the derivative of x to the fourth first. What's the derivative? Using the power rule, you get 4x cubed. Okay, then plus, take the derivative of x cubed. That will be 3x squared. And then minus the derivative of x squared. That's 2x. Plus the derivative of x, 1, minus the derivative of 5. Well, 5 is a number by itself, so the derivative will be 0. Okay? Let's say you want to take the derivative of 6x squared minus 5x plus 3. Okay. Again, we can take the derivatives term by term. Okay. So let's start with 6x squared. Well, what do we have here? We have a number times a function, 6 times x squared. 6 is the constant. So remember, when this happens, number times a function, we don't change the number. So 6 is not changed. And you only take the derivative of x squared, which is 2x. Okay. Next, we have minus 5x. Okay, 5 doesn't change. And you only take the derivative of x, which is 1, plus the derivative of 3 is 0, because 3 is a number by itself. And if we simplify, we get 12x minus 5. And that's our final answer. Let's find the derivative of 5x to the third power minus 2 over x plus 4 square root of x. Okay. Again, we can take derivative term by term. All right. But notice that over here we don't have x to the n, and we also don't have x to the n in here. So we will first rewrite this expression so we have our terms in the form x to the n. So the first term is already given in the right form, so I'm not going to rewrite it, but I'm going to rewrite this term. I can write it as 2 times x to the minus 1, and this one I can write as 4 times x to the 1/2. Okay? So all I did is just rewrite the expression. I haven't taken the derivative yet. I still have to take that. Okay? So now I will do that. I will take the derivative. So starting with the 5x cubed, don't touch the 5. Only take the derivative of x cubed. That's equal to 3x squared. Next, we have minus 2 times x to the minus 1. Don't touch the 2. Only take the derivative of x to the minus 1. So that's minus x to the minus 2. And then plus 4x to the 1/2. Don't touch the 4. Only take the derivative of the function. So we get 1/2 x to the minus 1/2. Okay? And then you just simplify. And if we simplify, we get 15x squared. Minus minus become plus. 2x to the negative 2. 4 times 1/2 will be 2. Okay? And that's your final answer. Okay. Let's move on to the next rule. Product rule. Suppose you want to take the derivative of a function times another function, so a product of two functions. Well, it's a common mistake that some students make. They say that, okay, if I have f times g, then the derivative is just f prime times g prime. Well, that's wrong. You can't do that. You can't just take the derivative of f and multiply it by the derivative of g. It's not going to work out this way. Instead, the answer is a little bit complicated, a little bit. So in this case, the derivative will be f prime times g plus f times g prime. Okay? This is what we call the product rule, right? And so anytime you see two functions multiplied with each other, you have to follow this formula. So let's do an example. Let's say you want to take the derivative of x squared plus x times 5x minus 1. So here we have two functions multiplied with each other, and we want to take the derivative. Our first function, x squared plus x, think of it as f. Think of it as f. And the second function, 5x minus 1, that will be our g. So we have f times g. And now let's follow the formula to get the derivative. So what does the formula say? First, you need to take the derivative of f prime. So differentiate this. Well, what's the derivative? X squared becomes 2x, and x becomes 1. Times g. So times g, you don't have to do anything to g, you just copy g. So times 5x minus 1. Plus f, so you just copy f, don't do anything to it. Copy f. Times g prime. So multiply by the derivative of g. So what's the derivative of g? Well, 5x becomes 5. 1 becomes 0. We don't have to write it. And then you just simplify your answer. Okay? Let's do another quick example. Let's say we have 5x to the 4th minus 2x times x cubed plus 2. And you need to differentiate. Again, we have a function times another function. Okay? So this is your f, this is your g. Again, we'll just follow the formula. First, you take f prime, So if this is f, f prime will be, let's see, we have 5 times the derivative of x to the fourth is 4x cubed minus the derivative of 2x is 2, right? Because it's 2 times the derivative of x, which is 1. So that's f prime times g. So we'll just copy g. Then plus f. Plus copy f. 5x to the fourth minus 2x. Plus f times g prime. So multiply by g prime. So this is g, and g prime will be 3x squared. Okay? And then you just simplify and get the final answer. Right? So that's how the product rule works. So anytime you see two functions multiplied with each other, you need to use the product rule. So the only remaining case that we haven't talked about is when two functions are divided. And that's called the quotient rule. Quotient rule. So suppose you want to take the derivative of a function divided by another function. Okay? So again, some people think that it's just simply f prime divided by g prime, but that's wrong. You can't do that. Can't do that. The answer again is a little bit more complicated than this. What you do is you take f prime times g minus f times g prime, and you divide it by g squared. This is called the quotient rule. The way you can help yourself memorize the quotient rule is, if you notice, the numerator here is very similar to the product rule formula. It's very similar, except instead of the plus, we have a minus in here. In the product rule, you had a plus, but this one has a minus. So it's very similar to the product rule, and then you divide by g squared. Okay, so they kind of look similar to each other, the quotient rule and the product rule. Let's do a couple examples. So suppose you want to take the derivative of 5x squared minus 3x minus 1 divided by x squared plus x. Okay, so we have a function on top. So this whole thing is one function. Think of it as f divided by another function. Okay, so we have f divided by g. We need to use the quotient rule to take the derivative. So let's follow the formula and see where it takes us. So what does the formula say? It says first you take f prime. So this is our f. Then f prime will be, let's see, 5x squared becomes 10x minus 3x becomes 3, and the 1 is 0. So that's f prime. Times g. Times, so you multiply by g. You don't change it. You just copy g. Okay, times g. Then minus f. You copy f. You don't change it. 5x squared minus 3x minus 1 times g prime. So here's your g. G prime will be 2x plus 1. 2x plus 1. Okay, so we have f prime times g minus f times g prime, just like the formula says. And then in the end, you divide everything by g squared. So this is your g. You have to square all of g. That's what the formula says, g squared. So that's how the quotient rule works. Let's do one example to wrap it up for the quotient rule. let's say you want to take the derivative of 5x minus 1 divided by x cubed plus x. Okay, so this is f and this is g. You have f divided by g. You have to use the quotient rule. So again, just simply follow the formula. The formula says start with f prime. So here's f. What's f prime? Well, 5x becomes 5, and this becomes 0, right? So all I get is 5 times g. So just copy the g times x cubed plus x minus f. So copy f, 5x minus 1 times g prime. Here's your g. G prime will be, okay, this guy will be 3x squared plus, and this guy is 1, right? And you divide everything by g squared. So this is g. You divide by g squared. And then you simplify, and that would be the end of it. Okay? And before we finish, I want to connect again the idea of the derivative to the idea of the slope. Suppose we have the graph of the function x squared minus 4x. Okay? And let's say I pick a point on the graph. And I tell you that the x-coordinate of this point is equal to 5. And I will ask you, what's the slope? Okay? So what's the angle of the graph at that point? Well, as we said before, the slope is given by the derivative. So slope equals the derivative at the x-coordinate. So it's f prime of 5. So we need to find f prime, and then we plug in 5. That will give us the answer. Let's do that. What's f? What's our function? Well, this is our function, right? This is f of x. So if f of x equals x squared minus 4x, then what would be f prime? The derivative. Well, x squared becomes 2x, and 4x becomes just 4. That's our derivative. So now we can find f prime of 5. If I put 5 in here, what happens? So put 5 in here, the 10 minus 4 equals 6. So f prime of 5 is equal to 6. So that means the slope equals 6. Okay? If I pick this point on the graph, and want to know what's the slope, well, again, use the same idea. We know the slope is given by the derivative at the x-coordinate. And what's the x-coordinate of this point? Well, the x-coordinate of that point is 0. So the slope will be f prime of 0. Again, go back to the f prime formula. F prime of 0 would be, just put 0 in here, and you get negative 4. So the slope here is negative 4. Okay? So here we have a negative slope because the function is going down, it's decreasing. Here we have a positive slope because the angle is positive. Thank you for viewing this lecture. Next time we will talk about the derivatives of the sine, cosine, and other trig functions, as well as the chain rule.